Hi, this is Janak Reddy Dubbaka. One day, one NCRT concept. Today, day 5. In this video, we are going to discuss some more problems from motion in a straight line. Download a DJRPhysicsSir app from Google Play Store. It is absolutely free. See here. A drunkard walking in a narrow lane takes 5 steps forward and 3 steps backward. Followed again 5 steps forward and 3 steps backward, and so on. Each step is 1 meter long and requires 1 second. Plot xt graph of his motion. Determine graphically and otherwise how long the drunkard takes to fall in a pit 13 meters away from the start. See, this is the graph, xt graph. See, drunkard takes 5 meters forward, 5 steps forward. Each step is 1 meter, therefore total 5 steps, 5 meters. This is a 5 meter. And 3 steps backward, from 5 to 2. Like that, 5 steps forward, 3 steps backward. 5 steps forward, 3 steps backward. Forward, backward. And finally, and this is a 30 meter, he fell into the pit of 30 meter, at a distance 30 meter. Therefore, total time is 5, 8, 13. Therefore, 8 plus 5, 13. 13 plus 3, 16. 16 plus 5, 21. 21 plus 3, 24. 24 plus 5, 29. 29 plus 3, 32. 32 plus 5, 37. Therefore, finally, he fell into the pit at a distance of 13 meter in a time 37 seconds. See here, a car moving along a straight highway with a speed 126 km per hour is brought to stop within a distance of 200 meters. What is the retardation of the car? Assumed uniform, and how long does it take for the car to stop? See here, stopping distance S is equal to U square by 2A. Here U is equal to 126 km per hour. 126 into 5 by 18. 18 1, 18 7. Therefore, this is 35 meter per second. So here, I have to find out the retardation. Therefore, A is equal to U square by 2S. This is 35 into 35 by 2 into S is given as 200, and this becomes 3.06 meter per second square. And next one, stopping time T is equal to U by A. U is given as 3.06, 35. U is 35. Retardation is 3.06. This becomes 11.4 seconds. See here. Two trains A and B of length 400 meter each are moving on two parallel tracks with uniform speeds 72 km per hour in same direction. With A ahead of B, the driver B decides to overtake A and accelerates by 1 meter per second square. If after 50 seconds, the guard of B just brushed past the driver A, what was the original distance between them? See, this is the train A, length 400 meter. And this is a train, this is train B, and this is train A, 400 meter. Initial distance between them is T. Here, the driver of B crosses A. See, here the guard of A crosses the driver B in a time 50 seconds. This we have to solve in a relative velocity method. First one, relative velocity, initial relative velocity. Velocity of B with respect to A. This is UB minus UA. Both are moving with the same velocity. Therefore, initial relative velocity is 0. And acceleration of B with respect to A. Acceleration of B minus acceleration of A. The train A moving with an acceleration 1 and A is moving with constant velocity. Therefore, 0. This is 1 meter per second square. Here, the relative distance, relative distance B with respect to A, UBA into T plus 1 by 2 AB VA t square. Here initial relative velocity is 0, but acceleration is 1, time is 50 square. Therefore, relative distance is equal to 50 square. This becomes 1250 meter. But here, relative distance is equal to initial distance between the trains and the length of train A and the length of train B. This is given as 1250, and D plus 400 meters. This is 400 meters. Therefore, initial distance is equal to 1250 minus 800. This becomes 450 meters. This is the distance, initial distance between the two trains. See here, a point traverses 3/4 of the circle of radius r in a time t. The magnitude of average velocity of the particle in this time interval is, see, if the particle started at A, moves like this 3/4 of the circle. Here the displacement is, it is the shortest distance between initial and final point. This distance is root 2a. Therefore, average velocity VAVG is equal to displacement by time. Displacement is root 2r time t. Therefore, answer 3. See here, an object is moving in a straight line according to the curve given in the equation x is equal to t square. Find average velocity for the interval t is equal to 1 second to t is equal to 3 seconds. So here x is equal to given as t square. At a time t is equal to 1 second, x1 is equal to 1. At a time t is equal to 3 seconds, displacement x is equal to 3 square 9 meters. This is 1 meter. Therefore, average velocity x2 minus x1 by, this is t2 minus t1, 9 minus 1 by 3 minus 1, therefore 8 by 2. Therefore, PAVG is equal to 8 by 2, 4 meter per second. This is 4 meter per second. See here, two cars A and B starts from x is equal to 0, x is equal to minus 4 respectively along a straight line, and their positions is given by xa is equal to t square minus 3t and t minus 4. At what time they cross each other? Means when they are crossing each other, their positions are equal. Position vectors are equal from origin. Therefore, here xa is equal to xb. This becomes t square minus 3t is equal to t minus 4. This becomes t square minus 3t minus t plus 4 is equal to 0. This is t square minus 4t plus 4 is equal to 0. This is nothing but t minus 2 whole square is equal to 0. Therefore, t is equal to 2 seconds. Next one. A train starts move from rest at t is equal to 0. Its acceleration is a is equal to alpha t plus beta t square, where alpha and beta are constant. The velocity of the train at t is equal to 1 second. So here acceleration a is equal to dv by dt. Therefore, dv is equal to a dt. Therefore, velocity is equal to integral a dt. Here time 1 second, 0 to 1 second. A is given as alpha t plus beta t square dt. This becomes v is equal to alpha into t square by 2, 0 to 1 plus beta into t cube by 3, 0 to 1. Therefore, v is equal to alpha by 2 plus beta by 3. This answer. Next one. A particle moves a distance x in a time t according to the equation x is equal to t plus 5 whole to the power of minus 1. Acceleration. So here x is equal to 1 by t plus 5. If you differentiate, we can get velocity. That is equal to minus 1 by t plus 5 whole square. Therefore, here t plus 5 whole square proportional to 1 by v. Therefore, t plus 5 is proportional to v to the power of minus 1 by 2. Next one, acceleration a is equal to, this becomes 2 by t plus 5 whole cube. Therefore, a proportional to t plus 5 whole to the power of minus 3. But t plus 5 proportional to v to the power of minus 1 by 2. v to the power of minus 1 by 2 whole to the power of minus 3. This is proportional to v to the power of 3 by 2. Therefore, acceleration proportional to velocity whole to the power of 3 by 2. Next one. A constant acceleration acts for 20 seconds on a particle starting from rest. If the particle covers a distance d1 in first 10 seconds, the distance d2 in next 10 seconds. See here, when a body is moving starting from rest with constant acceleration, distance traveled in successive seconds 1 is to 3 is to 5. 1 is to 3 is to 5. Therefore, here this next second d2 means 3d1. That is equal to 3 into d is given as 20. D1 is given. Therefore, this becomes d2 is equal to 3d1. So, d2 is equal to 3d1. Therefore, answer 3 correct. See here, at x is equal to 0, velocity of the particle is 2 meter per second. Find the velocity of the particle when acceleration becomes 0. So here, when acceleration becomes 0, here is the first time acceleration becomes 0. See, for example, this distance I am taking x. The total distance is 3, 5 minus 2, and this becomes 3 minus x. See, from this triangle, this angle is theta, this one also theta. Therefore, tan theta is equal to, this is 4 by x, that is equal to, here, this is 6 by 3 minus x. Therefore, 2 2s are 2 3s are. Here becomes 6 minus 2x is equal to 3x. Therefore, 6 is equal to 5x. Therefore, x is equal to 6 by 5. That is 1.2 meters. Find the acceleration. Here, v square minus u square is equal to 2as. Therefore, v square minus u square by 2 is equal to a into s. Here, a is taken as y-axis and displacement is x-axis. Therefore, a into s, it gives area under ax curve. This is area. Therefore, here v square, initial velocity is given as 2, 2 square 4 by 2. Area, this is the area we have to find out, this area. And first area is a rectangle, that is 4 into 2. And the next one is triangle, half into base is x, that is 1.2, and height is 4. Therefore, v square minus 4 by 2 is equal to, this is 8, and this one is 2, 2.4, this is 12.4. Therefore, v square minus 4 is equal to 24.8, and v square is equal to 28.8. V is equal to, this is 2.4 plus 8, 2.4 plus 8, this is 10.4. This one is 10.4. Here 10.4 into 2, that is 20. Here is v square minus 4 is equal to 10.4 into 2, that is 20.8. Therefore, v square is equal to 24.8. V is equal to square root of 24.8. Therefore, answer A correct. See, these are the problems from day 5.